Good afternoon, everyone. Thanks for joining to our web series. Today we'll be discussing about the intelligent bot scheduler. I'm Vachan. I'm a machine learning engineer at Accelirate, and with me, Hocine. So he's an automation developer. So he developed many of the automation workflows, and he is a part of a intelligent bot scheduler team. So Intelligent Bot Scheduler is a new offering from Accelerate. We offered it recently. We kind of have a web application, the desktop application. So, so it kind of utilizes multiple machine learning models and multiple technologies in order to improvise the resource utilization. And there are other features in the bot scheduler, which I will be explaining in the next slides. Yeah. Okay. Before starting the bot scheduler, I will explain the bot orchestrator architecture. Um, you must be familiar with the RPA technology, where it can be used and how it can be used to automate the processes and all in from our previous webinar. And yeah, today I will be starting with the bot orchestrator architecture. So the bot orchestrator architecture in this particular slide is for the UI path. So for other platforms, it's more or less similar with few minor modifications, but the structure is almost same. So for RPA bots, we kind of develop the automation workflows in the UiPath Studios, and we deploy them as a Nugget package in the orchestrator, and it kind of acts as a pod. So whenever a new transaction for a certain process comes in, the bots will automatically execute those particular transaction, and it will dump all the logs, and it will dump all the logs and exceptions in reporting platforms like in general. We can utilize the Elasticsearch or Kibana. So these are kind of optional. So there are many other platforms we can utilize like Splunk and all those things. And the logs are logged in a SQL Server. So all the orchestrator logs will be logged in the SQL Server. So this is the architecture. Yeah, this is the Megan. Can you mute? Evan? Thanks. So this is the bot orchestrator architecture. So orchestrator will act more a kind of a control room. The orchestrator operator can uses access to control many things in orchestrator. For example, he can publish the updates as NuGet packages to bots, and he can stop the bot. He can start the bot. He can adjust various parameters associated with the bots. So this is the overall introduction to the bot orchestrator architecture. Yeah. So before diving deep into the intelligent bot scheduler, first I will try to explain what exactly is the process and what are the process definitions associated with the bot processes, right? So the bots are used to automate the certain process, and these processes might have a lot of factors and which can be standardized into all these factors. So these parameters are required to understand the feasibility, to understand the operations of the particular bot, and a lot of things. So these factors are important for the intelligent bot scheduler, and we will be ingesting these parameters into the bot scheduler. I will be explaining those things later. So the process definitions first, the process type. First factor is the process type. So the process type is whether the particular process is a transactional or procedural. Transactional or something like that, it will be having it will be executing a different transactions again and again. The same workflow, it might be have a lot number of transactions on a daily basis. It will be executing the same workflow for different transactions. Procedural are more related to a certain process which can be operated on a periodic basis. For example, running a monthly reports, running a weekly reports, and all those things. These are procedural. The bot frequency is when are we executing a bot, whether we are executing daily, weekly, or occasional. Start time and end time of a bot is more related to when that particular bot can start. For example, these are kind of configured within the orchestrator. So these bots kind of trigger automatically based on the bot start time and end time. bot start time is like, for example, we said that bot start time in the orchestrator is 8 a.m. or afternoon or something like that, based on the business requirements and application dependencies and all. So SLA is a service level agreement dependency. So it's like, so these SLAs are set by the business for the board. So it's more a kind of what is the deadline. So if we get the transaction for a certain process, how much time do we have to complete the transaction? For example, the SLA parameters are more like kind of 24 hours within 8 hours or something like that. So whenever a transaction comes into the orchestrator, we have to execute that particular transaction within that particular time, or else it would be considered as a SLA breach. Yeah, so the input cutoff is the time that we will be stopped, that bots will stop taking that particular transactions. And if the transactions come beyond that particular time, it will be executed on the next day. Yeah, the priority is a business priority. So whether that particular process is a high priority to the business, low, or medium. And VM and application dependencies are something like that. Bots cannot run on all the VMs, so it has a kind of a file dependencies, application dependencies, and all those constraints. So most of the bots have this particular dependencies that we need to take care of. So these are the process definitions that are required for intelligent bot scheduler to execute the processes. Yeah, so yeah, the traditional orchestration is without the bot scheduler, without our application. This is how the transactions are executed in the orchestrator, right? So there are broadly two types. One is predefined orchestration, and the second is a manual orchestration. The predefined orchestration, or more related to it, kind of they configure those parameters which I mentioned in the previous slide in the orchestrator, and the bots will consider those particular parameters for their operations. The first is the fixed time. The fixed time is, we specifically set the bot's start time and stop time. So the bots will start its operation on a start time and it ends on a end time. So irrespective of the transaction or volume, it kind of starts and stops at the same time every day based on the frequency. The count-based trigger is we execute the bots based on the count, based on the volume. For example, we will set that particular bot. So all these transactions will be coming in a what kind of queues. We use the queues in order to feed the transactions to the bots, right? So the count-based trigger are we execute the bots when we have a certain number of transactions. So these are the predefined orchestration. The manual orchestration is more kind of we don't have pre-configured parameters in Orchestrator. So we manually override those parameters in order to operate them by Orchestrator operator. Yeah, manual orchestrator is more, there are two types. One is the arrival based. So operator will be manually initiating, operator will be manually initiating the bots based on the demand, based on whether a business needs something or something like that. So the business SME execution are more related to human in the loop processes. So where we don't entirely automate a process, we automate a certain part of the process, and remaining things will be performed by the SME. So in that particular case, based on the SME requirements, based on whenever they are executing a certain job, they will utilize a bots and they trigger that particular bots to do the transactions. So these are the different type of orchestration used now. Yeah. So these are the so this is an example for almost like 50 bots. So this is called as a Gantt chart. So the Gantt chart for the bots, it kinds of gives us a good understanding how bots are executed in an enterprise. So this is the Gantt chart for the bot volume, right? So consider this as a more kind of a timetable. So this is the timetable for a day for almost like 50 bots. So now when you look into the blocks here, these blocks are the time when a particular bot is executed, when a particular bot is working. So as you can see, so different lines and different lines in this particular chart are for the different bots. As you can see, for example, in the first bot, this particular bot is started running at almost like 9 p.m. and it did perform certain transactions and it stopped there. So this is a Gantt chart for the bots. We have a custom application that we built. So once you integrate with the SQL database, it kind of produces that particular Gantt chart. Gantt charts are very useful in understanding the bot utilization. So when that particular bot is running, when that particular bot is not running, for the different processes, right? So this is a Gantt chart for a day, and you can see there are a lot of issues over there. So for some of the bots, the resources are overutilized. For some of the bots, the resources are underutilized, and some of the bots are kind of idle for a longer time. And these are kind of utilization for different bots. As you can see, these are very varying numbers. So we cannot say all the bots are kind of underutilized, all the bots are overutilized. It totally depends upon the bot volumes on a daily basis, business, a lot of factors are involved in it. So yeah, so this is the first thing we kind of integrate with the SQL Server to understand the volumes of an enterprise. And based on this particular insights, we kind of integrate the intelligent scheduler in a different ways in an enterprise. Yeah. So as I explained you before, what is exactly is the traditional orchestration and what are the problems in the Gantt chart? So these are the frequent issues from our clients where they are using a traditional orchestration. So the first thing is kind of a resource constraints during the high demand scenarios. So we have found a lot of processes, for example, in this kind of scenarios, like in COVID-19, clients are expecting a lot of transactions, a lot of volumes from in a form of transactions for a certain processes. So these volumes are more kind of 10x and 20x. So with the bots allocated for that particular processes, they cannot handle all the transactions. So there are a lot of SLA breaches. And the second is bot infrastructure underutilization. So underutilization for some of the processes where it might not require that amount of licensing time. Anyway, with the traditional orchestration, we are kind of allocating that many licenses where we can pick some of the licenses based on the insights and provide it to the other bots where it requires where it kind of faces the high volume scenarios. And the third is the continuous in the traditional orchestration, continuous monitoring of a bot schedules are required because they are not sure about the volumes and they need to keep an eye on the bot schedules on a daily basis in order to see where they can improve the efficiencies and how its operations and all those things. And SLA breaches is one of the common thing because we are not allocating the licenses in an optimal way to the processes. There are a lot of SLA breaches that companies are facing because of the problem. And the volume limitation is more related to, for example, if we allocate a fixed number of resources to the processes, there will be always a kind of a volume limitation that we will be always facing, that the particular bots cannot handle high volume transactions or the transactions above the normal. All these constraints make that particular transactions to take more time, so which leads us to the increasing processing time for the bots. And the final thing is low intelligence. So with the traditional orchestration, we don't have any intelligence about the bot operations and how it's going to be performed in the future. So these are the issues in the traditional orchestration. So we tried to solve all this issue using the intelligent bot scheduler. So this is an example for a certain process, how how the volumes are coming in. So a certain process, there might be one or more bots based on the volume, and the time series is nothing but how much of licensing time a particular process took in order for the execution, right? So this is the observed. So this is the time series. The time series tells us, like, on a daily basis how that particular total licensing time for a certain process is a kind of varying. As you can see, there is a lot of variance in that particular licensing time on a daily basis. So these variants might depend on a lot of issues. It might depend upon the business. It might depend on other factors. But these things are very hard to figure out by ourselves without the machine learning models. And yeah, so this is the observed time series. As you can see, there are a lot of spikes and there are a lot of something which goes beyond the minimum points and all those things. So there is a lot of variance. And yeah, so these are the trend and the seasonal factors, right? The trend is nothing but, for example, if that particular process is getting high number of transactions over the time or increasing transactions over the time. So these are the trend. So increasing number of transactions, decreasing number of transactions. So this is for the entire year, right? As you can see, there are some certain trends which are kind of increasing, decreasing factors. The seasonality is something like, for example, that particular process might expect high volume on Fridays, or it might expect high volume on month ends and all those things. So these are the seasonal factors. So this particular time series is decomposed in the trend, seasonal, and these are the random residuals, are nothing but the random factors which we cannot encounter. So yeah, so this is an explanation of how that particular bot volumes are varying across the time period, across a 1 year for a certain process. Yeah, so now we explain all this bot volumes and how it kind of varying across different processes and all those things. So now we know what are the issues that traditional orchestration is facing, and now we need to kind of utilize the we thought we need to kind of utilize all the machine learning and RPA technologies to build the intelligent bot scheduler to solve all the problems. So intelligent bot scheduler is a mix of RPA and the machine learning models. What it does is it kind of utilizes the historical data which logged as a transactional logs from the database. It kind of utilizes all the data and it builds the model, and then it uses the machine learning to build the model in order to kind of optimize all the resource allocation. So what it will do is the intelligent bot scheduler has two separate models. One is the process volume prediction, and second is the arrival time predictions. So these two models will predict for a certain day which process requires how much of licensing time, and when can we expect the transactions coming in. So for example, let's say if the models are predicting a process P1 might require 20 hours of licensing time, right, on a daily basis. But we don't know when that particular transactions might come in. It might come in the morning, it might come in after hours, and all those things. So the arrival time prediction model will predict when that particular transactions will be coming in. So these models will utilize the historical data to predict these two factors. Once we kind of predict the volume and the arrival times, we can give the licensing for the bots accordingly. So we will be solving a lot of problems here. We will be increasing the resource optimization. We will be we will be giving them a better intelligence. We will be avoiding as many SLAs as possible. So there are a lot of advantages, right? So these are the components in the bot scheduler. First is the data ingestion modules, where we integrate with the orchestrator database to gather the historical data for the models, and the process volume predictions and arrival time predictions I explained to you. These are the machine learning models. Once we have all these insights, then we need to create a custom schedule. So the schedule, the Gantt chart schedule I showed you, this that was using a traditional orchestration, right? So now we have all these insights. So now we will be creating a better schedule, which is a more kind of a timetable that we provide, that we generate on a daily basis, so that the orchestrator can utilize in order to increase the operational efficiencies. So yeah, so there are a lot of process parameters, for example, start time, end time, SLA, VM dependencies, and all those things. So we will be considering all those parameters while generating the schedule. Yeah, so this is the architecture of the bot scheduler. The first is the orchestrator or control room DB database. So where all the logs are stored. So the processing modules will take that particular data through the APIs, and it will pass through two models. One is the volume model and arrival time model. So this will exactly give us when can we expect the processes and how much licensing time is required for each process. So then we utilize the process definitions. The process definitions are defined for processes which are more related to the particular process should be placed on this particular VM and this particular VM, or it should stop in the 8 in the morning and stop for the evening and all those things. These are the parameters set by the business. So we utilize the process definitions and the insights from the model to generate the optimized schedule. So once we generate that particular schedule, we push that particular schedule to the scheduler database. So the bots or APIs can take the data schedule from the scheduler database, and it can automatically place that particular schedule in the orchestrator. So the bots will be running on the optimized schedule rather than the traditional ones. Yeah, Hussein, can you explain additional scheduling challenges and?
Absolutely. Hello, everyone. My name is Hocine, and I'm an RPA developer here with Accelirate, and I was part of this the team that worked on this project from an RPA side. So I'll talk to you about some of the additional scheduling challenges and how we built a bot to automate the scheduling process. So the first challenge is actually when you have a new process. So once you develop a new process and you push it to production, I mean, you got two options. So whether you spin up a new resource or you try to fit it within your existing resources. The second one is terminated sessions, and that would be when you have an automation that was running and then it terminated, and especially if it runs overnight. You come in the morning as an ops a person within the ops team, you see an automation that terminated, obviously you'll try to investigate the issue, and by the time you fix it, the process has missed its schedule, so you can't fit it back to its original schedule. So you would have to find a new block of time in order to run the process. The third one is an ad hoc runs. So these are runs that run. These are processes that run periodically. Usually the business sends a request to the ops team asking them to run their process. And usually the load varies from run to run. So then the fourth one is the increase or decrease in processing time. So if you have a set schedule and few of your processes picked up volume in the past, let's say a few weeks or a few months or whatever, it's going to affect the next schedule. So obviously they're going to take longer time, and you're going to have to go back and readjust these schedules periodically. And then the last one is the SLAs. So regardless of which of the situations, you want to make sure that you're assigning enough resources and enough time for your processes to complete their work within the SLA window. Can we go to the next slide, please? Yeah. So so basically to solve a lot of these issues, we combined a machine learning prediction with an RPA bot to automate the scheduling process. So basically on the left side you see the ML script which Vachan and his team developed. So it runs every day and it creates a schedule. That schedule has the name of the process, the resource it's going to run on, the start time and the stop time. And it'll insert that data into the database table, which the intelligent scheduler on bot on the right is going to read from. So it'll read that data, and then basically it'll load it into its queue. And then for each item within that queue, it'll assign a process to a specific resource. And you could do that with command lines or with APIs, whatever you have available. At the same time, if you see on the left side, there's the user has access. So basically, the ML script generates that prediction and then inserts that data into the database table, but at the same time, it creates a file that has the same data. So the user, which is the one of the or the ops team, have access to that file. When they open it, they see the schedule for that particular day, but at the same time, they have access to the available blocks of time, so they can see all the available blocks. And if they have any of the scenarios that I mentioned before on the previous slide, let's say like it's a terminated session that they need to rerun, or it's an ad hoc request that they need to run, they can use those empty and available slots. And then all they have to do is they have to put the name of the process, click a button, which is tied to a macro that inserts that data into the database table, which in return, it'll feed it to the intelligent scheduler bot that will pick it up and run those processes. And with that, I'll hand it back to Vachan in case he has something to add.
Thanks, Zane. It was excellent. Yeah, so I will explain what are the features of the bot scheduler. As Zane explained, how we integrated the machine learning models with the RPA. So now the intelligent bot scheduler will will generate the schedules on a daily basis. So it kind of utilizes the historical data in order to understand the processes better, and it will produce the schedules on a daily basis. So it kind of retrains automatically on a daily basis for the better performance. And the second is the change in the configuration can be easily done. For example, all the process definitions that we are utilizing can be easily altered, and it will increase the resource optimization, and it will give you better understanding of the process intelligence, right? So the process intelligence is one of the important things that's required for the better optimization, or the better insights in order to understand how the volumes are coming. And yeah, this will give us better intelligence on the processes. And yeah, and it can be integrated easily with the existing logging and the reporting capabilities in an enterprise, so we can monitor on a daily basis. So we have visualizations that we can easily monitor how this particular bots are evaluating, how these particular bots are performing, and what is the kind of increased efficiencies by using an intelligent bot scheduler. So all these modules are entirely automated. So we don't require any changes or oversight is required in order for the operation of the intelligent bot scheduler. Yeah, so this is the end of a bot scheduler. If you have any questions, please ask in the chat window.
All right, cool. There are a couple questions, Vachan. The first one, it says, can this be used for all processes or just specific ones? Is there a way to shortlist processes for the scheduler?
Yeah, sure. That's a good question. Yeah, so there are few limitations because these are machine learning models. It cannot be implemented for the processes which are new. So we kind of put that particular threshold as at least that particular process should be 1 month old in order to gather enough data. This is the biggest limitation. Other limitations can be handled internally by the bot scheduler.
All right. Next one says, what are the requirements of implementing the bot scheduler into our enterprise?
Yeah, that's a good one too. The requirements are very simple. So all we need to do is we need to establish a connection with the SQL database where the enterprises store the transaction logs. Once we build the connection with that particular SQL databases, then the models can train automatically and it will give the performance. So then after that, the second phase is a kind of integration with the orchestrator or control room based on the technology or P technology. So these are the two requirements. Once we have access to both of the platforms, then it's easier to integrate.
Okay. It looks like there's two more questions. The next one says, How much data is required for building the models?
Yeah, so this is a question like not easy to understand unless we kind of see the data. The important limitation is we kind of put the threshold as like at least we should having 30 days worth of data. For some of the processes, we don't require 30 days of data because we don't see much variance or volatility in the volumes. So it can be easily done. So we have a separate kind of feasibility study to study all the logs and figure out whether the particular process is feasible or not. If the process is not feasible, then we will be using the scheduler in a kind of a default way. So we will not be altering schedule for that particular process. We will be considering that particular process as other, and we'll be using the existing schedule to run the processes.
Okay, and last one. Is this a web or a desktop application?
Yeah, so this particular application can be customized. So we recommend more a kind of a desktop application because of the data issues. So it can be used as a web too. So there are two separate applications. One is a more kind of a pre-bot scheduler, and one is a post-bot scheduler. So these will be more a kind of desktop applications, but we have option to configure it as a web application too.
Okay, perfect. That was the last one.
Thanks, everyone.